Good afternoon. Thank you for having me. I'm the healthcare technical lead in the region for Amazon Web Services, which is the cloud computing arm of Amazon.com. And we work across the healthcare continuum. So I work on projects that are nationwide transformations in the region, from electronic health records, medical imaging, bioimaging, genomics, clinical trials, biomanufacturing, everything around generative AI. We create chatbots, we create digital twins. So we do a lot of different things, even working on medical drones that deliver medications and drugs to remote areas. But today I was asked to touch upon medical imaging and on open data. So I will try to do justice to the teams that are working exclusively on that on AWS. And I wanted to start with an example, a case study coming from the HSMI's Genelia Research Campus that is touching upon these two topics. It's touching upon how we accelerate research in the cloud, and also how this research can provide another way, another platform through the open data on AWS for other researchers to also use the same data and as positive negative controls and do further analysis. And here you can see this study that is essentially the hypothesis was, how do neurons traverse the brain and how do they form circuits? But when we're thinking about it, tracing neurons in large image volumes relies on direct volume rendering that is requiring terabytes of data to be moved from storage all the way to GPUs, to graphic processing units. And in addition, moving data across the internet is also time consuming, and sometimes it can take days or even weeks. And to address these issues, we moved the large brain image volumes to AWS, and we brought essentially the users, the researchers, and their collaborators to the cloud to do the analysis and access the data using Amazon AppStream 2.0. And you can read the technical blog where you can see also the reference architecture. And also you can see here that you can find directly the data itself. So when we're thinking about what the cloud is doing, essentially the cloud is providing you near unlimited storage and compute capabilities at your fingertips, and also access to more than 130,000 partner softwares. So the AWS Marketplace provides you different types of software that could do processing, visualizations, many different techniques. And these are also available with just by clicking on them and start using them and deploying them in your cloud environment. And one basic question is, how do we process this big data and do multi-modal analysis, not just analysis of bioimaging or medical imaging, but correlating this data with data that might be coming from patient records, from genomics, or from pathology data, or even in the healthcare space with insurance policies, and taking more informed decisions on diagnostic pathways and therapeutic pathways. And I think this is the main, the cloud is the main enabler for this type of secure and collaborative environment. And of course, we don't only provide the environment to collaborate, but you also have this extra computing, that it could be supercomputing, it could be quantum computing, it also could be different types of machine learning and generative AI. And I think that both in bioimaging, but also in medical imaging, definitely biology, we see disruption in the field. Pretty much every single user, hospitals, academic medical centers that are currently using medical imaging in the cloud are already deploying automations whereby you can have automated diagnosis through a LLM that is pre-trained on just this domain, so that the doctors don't have to do diagnosis from scratch. And how can the cloud help manage the ever-growing image data? We had several presentations, and I think it's understood in this group that this is one of the main issues that the cloud is solving, clearly the storage and the compute, because otherwise it's not sustainable to always just invest on private data centers and private racks. And globally, we have over 3.6 billion imaging procedures that are performed annually, and this number continues to rise every year. And compounding to this challenge, the typical image study, the size of it has doubled in the past decade, and now it's averaging 150 megabytes. And here, there have been bigger sizes that have been mentioned at the terabyte scale as well. So this, and we have seen also the digital pathology space that is also accelerating as well the need for compute and storage. So amidst this data deluge, we see that a lot of customers that now realize that cloud computing is the way, not only to have capabilities for storage, but also to have access to the latest compute and to the latest technologies or software that are available. So when we're thinking now, how do we design these different roadmaps? We have this concept at Amazon, it's called the flywheel. And here you can see just one high-level example in the field of biomedical imaging. For example, we have cloud-based workflows that can streamline the acquisition, the processing, and the analysis of data from various imaging modalities. Every lab has many different instruments, have many different CT scan, ultrasounds, MRIs, you name it. And so imagine a seamless journey where imaging data from instruments can automatically ingest into the cloud, into one data lake or health lake, where we can have also standards, for example, fire standards implemented. We can also create a machine learning model that is, after the data is harmonized and wrangled and they're cleaned, then we can have the machine learning triggered automatically and providing probabilities, also providing quality control, image enhancement, automated annotation, you name it. We can trigger many different workflows. And also we can automate notification of new imaging data when this is available. And so make all of this frictionless and seamless. And of course, another key enabler is the preservation of data provenance and its lineage and the minimization of data movement. So we are trying to create essentially efficient storage management. And when we're thinking now of the high-level benefits, these are three categories, I would say. There are many different ones, but I would say the first one would be high availability and reliability. A good example on this domain would be the University of California Health that deployed in the cloud their architecture, and they managed to have their medical imaging enterprise platform across all of their different centers, the medical centers. And essentially they have, they use a multi-availability zone architecture for virtually no downtime. In the second domain, I would say that, of course, cost is always an issue, and security, the safety of the data. Here, an example would be the King Hamada University Hospital that has 600 beds, so it's one of the large hospitals, and archive medical imaging data with AWS and save 40% of storage costs. And on the third pillar, we have scalability and performance. And here, as an example, Alina Health replaced on-prem packs, the picture in archive system, with enterprise imaging in the cloud, and they reduce 67% in image retrieval times. So definitely you can have quantifiable results immediately upon using the cloud. So, but cost is not just the only consideration. Researchers and clinicians must be able to view the images as fast as possible. And I wanted to show you at a high level, we have more than 200 services, as I said, from digital twins all the way to robotics, but I chose AWS Health Imaging for you today. And this is a service that allows you, it's a HIPAA-eligible service, that allows you to revolutionize how you manage the medical imaging archives. It stores a single authoritative version of each DICOM image and separates the metadata from pixel data for efficient access without loading the entire data sets, and it has a lossless compression. And it allows also to have up to 40% reduction of costs. So, and you can link it with OHIF and other types of viewers so that you can have access to your data and analyze your data in the cloud. And another platform, another partnership that I wanted to highlight as an example of what type of research capabilities the cloud is enabling. I want to highlight the partnership with Roundbound UMC that has opened up new opportunities to accelerate the global medical imaging ecosystem and the research community. And today, the Grand Challenge platform has grown to over 70,000 registered users across the world, and they have over 300 diagnostic imaging AI challenges every year. We have many different ones. I have a few of the examples here from Tiger, the Leopard, the AROG, so there are many different ones. And they have also more than 1,000 unique algorithms deployed. And so this just tells you how fast things can scale in the cloud, and it's really, truly wonderful to see. Of course, we have a big network of partners in the medical imaging space. Zeiss also presented before me, so this is one of them. But when we're thinking now about the open data program, I want to switch a little bit gears. So when we think about open data at AWS, we believe that sharing open data in the cloud lets data users to spend more time on the data analysis rather than on just data acquisition and how they can store them and transfer them. That might take a lot of time. So this leads to reduced time to insight, lower cost, and new services and tools that can be developed. And of course, the global community of users, which is an element of this community as well. And when we're thinking about the open data program, there are two main pillars. I would say the first one is the registry of open data, which serves as a catalog essentially to listing all of the data sets available through the program. And the registry provides tools and usage examples to help data consumers and data researchers, for example, to understand the effect and effectively utilize these data sets. And you can see here that we have more than 100 usage examples. We have tutorials, we have publications and technical blog posts on how you can use them. And the second one is the sponsorship program. And the open data program does not just have high value data sets, but we want to create a program that has wrangled, annotated, labeled data that can be used for more advanced type of research. And we cover the monthly cost of the storage, and we also cover the ingress. And the ingress is the cost that is associated with data going out of the cloud. So this is completely free. And the main principle of the program is that no paywall registration should be required to access the data, except in the case where there is protected health information, where we have more stringent rules. So we really encourage everyone to use this program. It's free, and you can explore also the different types of data sets that we already have stored in the cloud. And just to show you on a high level, we're very fortunate to work with these customers and discover ways that the cloud can expand their access to data. This is just a few. We have way more. Please go online and check it out. And here's just an example of open imaging data sets on AWS. There are medical imaging data sets like the Imaging Data Commons from NIH, the cell imaging data sets from Allen Institute, the Chan Zuckerberg BioHub, and the electron microscopy data sets as well. I think they're more relevant to your community. Please do use them. And just to give you a taste of what these data sets look like, essentially this is the open cell data set from Chan Zuckerberg Institute, and it shows the different localization partners of more than 1,000 proteins in the cell. And this data set has all the raw images from the study at the registry on AWS, and you can download them and use them for your research. And here you can see how researchers are using open imaging data to teach the next generation. So as a training tool, they use them to train machine learning models based on imaging data. And also we have other types of efficiencies and capabilities. For example, you can manage your digital microscopy data using Omera on AWS, which was one of the, which was mentioned in the morning sessions. It's also something that you can use in the cloud. And before I close, I wanted to give you an overview of one more service, which I think it might be very useful to you. It's called AWS Clean Rooms, and it's allowing essentially researcher centers and academic medical centers or universities to collaborate in the cloud without sharing the data. So essentially you can form a little hub in a cloud environment in AWS Clean Rooms. And without sharing any of the data, without sharing or revealing the underlying raw data, you can do common analysis on the data set and publish your results. And finally, my final slide is about the different programs that we have to enable the community. This year we had the Health Equity Initiative that just finished the last round last month, and we have given away $60 million on different projects that are enabling access to research, medical research, or to democratize access to healthcare applications. And we also have the Amazon Science Research Grants. It's the first one you can go and see. It's every quarter we have different types of applications that you can also submit. We have the Imagine Grant Award and the AI for Change Making Awards, among many others. Please go online, and we would love to hear from you. Thank you.